My project is a Java API that will allow an office or any other organisation to develop their own grid processing system. It's built on the Java platform, so it'll run on any operating system, pretty much except for iOS. It'll allow an organisation to quickly develop their own grid, deploy it. The grid works by finding underutilised systems and making use of the excess resource on those systems. For example, many office staff surf the internet at lunchtime, so their computer is only being used about maybe 5–10% of its capacity. That's 90% capacity which is being wasted, and investment money down the drain. JGrid works by seeking out that 90% processing power and making use of it, signing up to the grid. In general, what makes JGrid different is that systems are volunteered to the grid based on their utilisation. So we're making use of systems that, like I say, aren't being utilised enough. So we're getting an efficiency usage from our IT infrastructure investment.
So my project is an application for the service desk technicians at Plymouth City Council. I did my placement year there between the second and third years and noticed various inefficiencies with regards to going off-site to fix incidents. Therefore I've developed a solution to hopefully overcome the inefficiencies identified. So upon arriving on site to look at the incident, the user will be able to log in. And upon logging in, they should see a list of their currently accepting instances. These are only the ones that they've said that they're going to work on for the time being. But you can also search for an instance which will bring up search results by either reference number or by customer name. Upon selecting an instant that you're going to work on, you can see the entire core history, starting with the original instant text, moving up to the most recent one. You can add in updates to the core, like it's just updating, core updated, and you can see the time where it's automatically filled in with the date. Place an instant on hold if you need to, which will remove it from the list. It also stops the timers from going there, and if you needed to, you can navigate to them using Google Maps API. It searches for the postcode, and you can do a similar function with the telephone number there, and it automatically fills in the telephone number just there.
I've established two different perspectives of the same game world on two different devices. So from here you've got your standard first person walk around an environment view, and on here, as you see, you've got the tablet that's got a top-down view of the first person's game. So what happens is this is a series of levels that are here to prove the technology works. So, for example, first part of the game, you walk up, no stairs. I need the player two to tap both of the vases, which then causes the stairs to raise. Then the second level requires a bit more. So player one is required to jump from platform to platform, a simple platform mechanic. Player two needs to tap the balls to make them disappear in order to allow player one access. Unfortunately, quite hard to play with one person. Now that we've established that the technology works by sending the information from this game as the host to a localized tablet over a local area network, this enables us to build a set of localized cooperative games that could be used from PC to tablet, or tablet to tablet, or who knows. So,
my project was based on my placement company called iMath. They operate in the field of occupational health, and they have a current system called Absence Line, which is if an employee wants to log an absence from work, they would call a call centre, the call centre would log all the details, and then an email would be sent to your line manager to inform you you're not going to be in work. So I found a number of flaws with that system, in that if you've got an embarrassing absence reason, if you've got a reason which could be made worse through using a call centre, such as like laryngitis or a cough, then you may not want to exacerbate that through phoning. A number of different things which I thought could be solved if the process became more employee focused. So I developed a mobile app which employees can control their entire absence themselves and do it all via their phone. So here are the options to do with, so that would be your name. I'll just test an app account. You can log a new absence, or you can view current absence details. So we've already got an absence open here. Obviously it would be nice if it would all fit on one page, but there's a lot of information to show. So start date, end date, absence type. Also we'll just select this absence. So we can update, log return to work, or manage certificates. Certificates is if you're on a long period of leave, so say you've broken your leg or you're having treatment for something, you'd get a doctor's certificate. So you can add these here if you want to, and that'll like justify you having longer off work. So we'll just update the absence for now. So here's all the absence details we can update, and it's quite iPhone friendly in that you just tap whichever ones you want to update and do it that way. So we'll update further absence details and contact number. Those are quite two easy ones, and then they're all shown here. So further absence details, this shows the history of absence details and what you've added in before. So we'll just say still feeling unwell.
So you need to
say like doctor's appointment tomorrow. Because whatever you put on here will be sent to your line manager, and then they'll be informed. Then you get to show that it's been successfully updated. I'm set up as a manager on here, so we should get an email to this phone in, here we are. So it shows that an email's come through to say sickness line, absence line, sickness edited for this person. That'll get sent to the line manager, and then they'll see that you've updated your absence and can take it from there. It's exciting for me because I've learned a lot from it, and it's a direct reflection of what I've learned on placement, and it integrates. It's quite exciting in that IMAS could use it as a product themselves and just add it to their absence line branch. So because it runs concurrently with the current call centre system, so you could log your absence on the call centre and update it on your mobile. You know, it's quite cooperative between the two. So yeah.
What it allows you to do for skateboarders or BMXers is to find locations or record locations.
So my project is on improves the ordering process in establishments. So basically there's a problem with queuing times in establishments because the music's loud. It's hard to communicate your order to the bar staff, and often there's no menu, so you don't know what drinks are for sale and how much they are. So you end up making blind decisions on what drinks to order. As well as that, you don't know what drinks you've had, so in the morning after you don't know how much you've drunk or how much you've spent. So the system aims to give establishments a web application where they can go on and upload their information. That includes events, menus, drinks, the prices, works out the alcohol content and stuff. And then it gives clients, customers, a mobile application which consumes all the information on the web application through an API. So they get a list of all the establishments near them, and they can then filter those on on their current location within a certain radius, and they can then use the establishments to browse their menus and put drinks into an order. Once they've got an order sorted, you put your phone back to back with the bartender's phone and click send, and it sends the order to the bartender for them to go and order the drinks, fulfill the order. And then there's an order history tab where it shows you what orders you've made, how much you spent, and how many units you drunk. So there's nothing like this at the moment. Starbucks have got a similar application where you can browse their menus, but you can't order drinks on it. It produces a barcode that you can use to pay for your drinks on like your Starbucks account, but there's nothing like this around, so it's quite unique.
My project developed a development environment for obfuscating transformations. So it aimed to allow developers to design custom obfuscating transformations and therefore to secure their source code to their products. So it is an intellectual property protection scheme, and it also had a strong research component. So as part of the project we analyzed context-free grammars and various other technologies. So we started out by writing a computer program in dialective assembly, and we have several transformations as part of the polymorphic engine that we can apply. We define a transformation by registering an instruction that we want to translate in an alternative series of instructions in order to obfuscate the original intention of the instruction. So for example, let me disable some of the other extensions we won't be using. Okay, and this is the program source. All it does, we can check the compilation abilities. If I press build, you can see that build has been completed, and we have a disassembly doc on the right hand side, which just shows us what every single instruction disassembles to, its virtual address, the hexadecimal codes that correspond to that instruction, and the actual assembly mnemonics. If we take a look at that in a disassembler, it will look pretty much equivalent to the source, because assembly has a one-to-one translation, so there is no intermediary translation process like the languages like C and C++ that use higher linguistic concepts. So that's what the application compiles to. If we run the application, you can see that it just displays a simple message box. It contains three main components. It has a string, which is embedded in plain text. It has a message box and then an exit process. And in this particular case, we're going to obfuscate the jump instruction. The jump instruction simply transfers program control to a target destination. Let's switch it from compilation to obfuscation, and let's build it. And as you can see, there has been an increase in code on the right-hand side, because the jump instruction was rewritten according to a grammar translation, and this is a form of control flow obfuscation. It will jump in a trampoline fashion, in the sense that it will jump through three intermediary jumps before it gets to the final destination. Now, this is simply one iteration of the grammar translation, but if we were to turn up the complexity of this transformation, then we would see a recursive effect, because every single grammar can be modeled like a recursive function. So we will see a massive increase in code, which is here. As you can see, this has been increased by maybe 12,000% or so. And if we verify that it still runs, the application still runs. Therefore, we have preserved the semantics, which is really important, because if the program doesn't preserve semantics, it won't be the original program anymore, but it will be a different one. And if we take a look at the disassembly using a proprietary disassembler, okay, let me refresh this. And you can see that the code has been expanded into all these jumps. Every single jump contains an opaque predicate, which is a logical predicate that is known to the person compiling or the obfuscator itself, but it is not known to the disassembler. And disassemblers that use the recursive descent approach won't be able to figure out where the control flow is going, so they will have to disassemble all code, and this can result in misinterpretation of code, and therefore you can display ASCII as code and code as ASCII, and it will confuse a human static analyst. So if we scroll down, we can see that there's quite a bit of extra code, and eventually it leads to the original segment of the code which we have left intact. But over here you can see that the hello world is being misinterpreted as a bunch of x86 instructions, and that's because the assembler doesn't really know, not the assembler, but the disassembler doesn't actually know where the control flow is going to go. So we have successfully kind of deceived it in this way. We have tried something that has never really been tried before. Context programs have been analyzed in theory, but they haven't really been implemented. I don't think anybody has actually built a prototype and pinpointed some of the weaknesses that we have highlighted in a research paper that was produced as part of this project. And this gives us a pretty good idea about what the development environment is supposed to contain if it is supposed to give the whole breadth of complexity that is desired for these kind of applications.
My project is a way of managing Cisco study pods. It's been designed for Cisco. At the moment we have a one-to-one mapping between a learner and a study pod. This is pretty wasteful on resources because they might only be using the study pod for about an hour or two a day, wasting the other 22 hours of the day where it's just sat around doing nothing. It's wasting electricity, it's wasting heating resources and data center space. To combat that, what I've done is taken the existing study pods and created a cloud of study pods. Now, instead of having a one-to-one mapping, the users just book time on the cloud, and then the cloud automatically allocates them a study pod when it's their time for a booking. This allows us to use the same amount of study pods with hundreds more users across the world, increasing efficiency, saving on expenses, and allowing more people to study for Cisco qualifications. So when a user wants to book some time on a study pod, they'll come to the website that we provide. They'll then just need to specify what time they might want to work from. So for example here we'll choose between 3 o'clock and 5 o'clock. We'll then check the availability, and we'll see that there's different study pods available that they can work on, and they can see which configurations they already have saved on that study pod. We'll select this pod. We'll then have the choice to which configuration you want to work from. This will be useful, for example, if a student is studying a CCNP qualification, they can have the CCNP qualification configuration loaded from the start when they're ready to go. We'll choose this blank CCNA one for now. And that's all it is. So the system now has a booking in place, and at 3 o'clock the system will automatically provision a study pod for the user at that time. So the way it's worked, there's a back-end system that handles the management of the study pods. It uses SNMP, the Simple Network Management Protocol, to communicate, and then it provides a web front end for users to access and make their bookings. There's also a RESTful API which then connects to an iPhone app which provides the users the ability to book and modify their bookings. When a booking starts, the users are sent all the details of their equipment they'll be working on, the telnet and SSH details, and they connect just as they would with a normal device.
So my project is a simulated prosthetic hand for demonstrating prosthesis control systems. When you're training an amputee on how to use prosthetic control systems, it can be fairly counterintuitive to not have any visual feedback as to what they're doing. So the idea behind this is to just supply that feedback, really. Because getting access to robotic limbs, they're really quite expensive. So a good solution to that is just to have a simulation running on a computer. So currently the only software available is to actually do what this is doing now. It's really quite expensive commercial software. We're looking at like thousands of pounds, and there's only really one option developed by university. So this I'm offering up for free, so as an open source project. So. Okay, so at the moment it's just moving between random poses. It's not being controlled by a discriminator or anything. But you can see here how it animates very smoothly between different poses. So this system here, developed by a researcher here, it was just talking to my application using the network just to set the pose, which it discriminated from me moving my hand. So, it can also be controlled via serial for external systems as well.
For my project, I've created a digital scrapbook that is a hybrid application, so it's a web app in a native layer using PhoneGap, which means it can be run on Android, iOS, so it's iPhones, iPads, and can be ported to many different platforms really easily. We launched the application. The application has been created to fill a solution for the problem where people nowadays take hundreds and hundreds of photos when they hit an event, and actually it becomes useless because there's too many photos and you get overwhelmed. This allows you to create actual scrapbooks and pick out the bits that are important to you, so you sign in with Facebook. It uses the native Facebook application to sign you in there. And then it presents you all your scrapbooks, so create a new scrapbook. For example, I'm getting married next month, and a good demonstration is actually, there's going to be so many photos of my wedding, and it's not really going to be very applicable for me to actually sort through this and send this to people. So we can create a scrapbook for that. So this is an example, you would just go in there, and then because it's mobile, the application resizes to whatever screen size, so this is a tablet, it's going to have a bigger interface. So let's create a scrapbook here. You can choose the colour and customise your scrapbook to different things, and you can add in friends. That's pulled in automatically through Facebook. So like that's like Tim, and then we create our scrapbook, and that's now created it to the server live. And then you can edit it with your friends. So for example, let's change the page layout here. Change page 2. And you can go in and change and add in photos like now or in retrospective, or you can add in text, or you can add in different elements. And you can build up a really rich scrapbook of just the important events that matter to you. And you can go through and add different pages to this. There we go. And this is happening in real time, and everyone can collaborate with that. It's powered completely with HTML, JavaScript, and CSS, using cutting edge technology there. And one of the key parts of this, which was important for me, was to be able to allow people to buy these books and get physical copies. And so from this application, you can order a physical copy of this book that will be delivered to you automatically from the device, and everyone can purchase and get these books who's involved with it.
My project is a dementia assessment application using the iPad framework. We're aiming at testing people's motor skills and detecting their tremor as they perform these various tasks. It's a task that we've been working with the NeuroCore research department at Derriford Hospital. What we've been aiming at doing is we want to pilot this new application, because currently the assessments that are being performed are paper assessments. They're not accurate enough to the standards that we require them for prescription of new drugs that are coming out, which is in dire need because the new drugs that are coming out are so expensive. We must have an accurate assessment mechanism. So our intention is to create new assessments using digital technology, so we can more accurately pinpoint whether people suffer from dementia, whether it be Alzheimer's, Parkinson's or multiple sclerosis, at the mild cognitive impairment stage prior to the progressive stage, which is what we're now detecting. It works by using the accelerometers of the iPad. There are 3D shapes displayed on the iPad. They have to rotate these shapes by physical interaction with the device. This in turn requires them to interact in such a way that tests their apraxia ability. So the patient who is being diagnosed for dementia will take the application and rotate the shapes around. Their intent is on counting the amount of cubes the shape consists of. In this case it's 7, and then they enter in the amount of cubes like so. Then it loads the next model. These models get progressively harder as the app continues onwards, requiring them to have greater motor and spatial awareness. So this one here has 9, for example. As the application is running, we're constantly recording the accelerometer data, so any tremors or shaking that occurs is recorded. We get full readings, seconds, X, Y, Z coordinates of the tilt of the iPad. Therefore we can take these readings later on and analyse them to see if there are any patterns in tremor that we can use for earlier assessment of these diseases. What this means is we can take this application, as it is a pilot study, and we can go on and we can analyse this and intend to create bioprofiles of the main diseases: Alzheimer's, Parkinson's, multiple sclerosis, essential tremor, etc. And when people perform our test battery consisting of this app and other apps, we will be able to place them in one of these biopatterns and see if they are developing such diseases.